I'm sure you know what DNA is, or at least you've heard of it. But one thing you might not have heard about are transposable elements, or TEs. TEs, commonly known as jumping genes, were discovered by a scientist named Barbara McClintock in the 1940s. Jumping genes were originally thrown out by many scientists as junk DNA, but only recently have scientists begun to realize that there might be more to them than previously thought. So, what are TEs? Well, like the name implies, TEs are sections of DNA with the ability to jump from one area in the genome to another. Imagine it like this. Think of DNA as a line of toys. They all have to stay still. But what if one of those toys could move? It could rearrange itself anywhere it wanted, while the order of the rest of the toys had to stay the same. TEs are a big part of the human DNA, and by big, I mean they're around 50% of the human genome. So why are there so many? Well, as jumping genes move, they place copies of themselves throughout our DNA, effectively increasing and multiplying their numbers. There are many different types of TEs, but two of the main categories are retrotransposons and DNA transposons. Retrotransposons are a subcategory of TEs that require reverse transcription. Transcription is a process in which DNA is copied onto the RNA. Reverse transcription is when, rather than having the DNA copied, the RNA transcribes information from the retrotransposons and inserts it into the DNA. This method of moving is like a copy and paste function of your computer. The retrotransposons continue to make copies of themselves while leaving the original. The second main category are DNA transposons. These are a subcategory in which the TE does not require reverse transcription to move. Instead, they physically move to another location. Some cells make copies of the DNA transposons in order to repair the holes that they leave. DNA transposons are greatly outnumbered by retrotransposons, being only around 3% of the human genome. Today, most transposable elements are unable to jump. In the human genome, there is only one TE still capable of jumping, and that is line 1. Along with line 1, another TE called ALU is also still moving. Although ALU cannot move on its own, it manages to get a ride on line 1. They are responsible for creating a lot of genetic diversity. Because these TEs are still moving after birth, scientists have hypothesized that they even manage to create genetic differences between identical twins. So, why are TEs so important? Depending on where they land in the genome, TEs can be both beneficial and harmful. Because TEs land in places they were not originally supposed to be, they create mutations. These mutations can lead to evolution, and some scientists think that they are the reasons humans are humans. They have contributed to the formation of our immune system, they direct embryo development, and they help to keep our brains healthy. Although some negative impacts include cancer, brain disease, and they even put people more at risk for Alzheimer's. With study, one day scientists might be able to use them to do things like create synthetic embryos or find cures to cancer. Who knows what possibilities lie in wait with transposable elements?